I have the log of the square root of x squared plus 1 divided by x plus 3, and I want to expand this out into a bunch of different logs. So the first thing I'm going to do is turn this into a difference of logs, because I have this division. This is equal to log of the square root of x squared plus 1 minus the log of x plus 3. And it's best to put these in parentheses in order to not confuse this with a constant, just log of x plus 3. Log of x plus 3 is different than just being log of x plus a constant. Those are two very different things, so it's important not to get confused in a situation like that. So the next thing I can do is look at this and say that this is a power of 1/2, and therefore I can use the power rule to bring this out front. So this is now going to be equal to 1/2 log of x squared plus 1 minus the log of x plus 3. And this is as simple as this is going to get. So that wasn't bad. Let's do a couple more. I'll change into a different color. How nice. This time I'll do the log of, try and make it a little bit confusing, the square root of x times the square root of yz. So I'm taking the log of a square root, and then underneath that there's another square root. So how do I start with something like this? And there are a couple of different ways this can be done. It can be, these two terms can be separated out to a sum, or we can start with the power rule. And I'm going to start with the power rule because that's what I like doing. So this is going to be equal to 1/2 the log of x times the square root of yz. Now I'm going to use the multiplication rule and write this as the sum of two different logarithms. And it's important to know that this 1/2 is going to be distributed to both of them. It can be thought of as this. I want to do it this way first. This is equal to 1/2 times the log of x plus the log of the square root of yz. And then this 1/2 will be distributed to both of these logarithms. So this is equal to 1/2 log of x plus 1/2 log of the square root of yz. So it's possible to write that out every time, but through practice and repetition, many people won't even need to do that step to remind themselves that it needs to be distributed. They'll just know from experience. But anyways, now that we have this right here, I can see that this can be simplified a little bit more by the power rule, or we can use the sum rule first, or the multiplication rule. Doesn't matter which one goes first. I like doing the power rule first. So if I use the power rule on this term, I'm going to get 1/2 log of x first plus 1/4. So 1/2 times 1/2 is 1/4 log of yz. And now the last step is to write this out as a sum of logarithms. And again, this 1/4 is going to distribute to both of them. I'm not going to do this again this time, but I did it the first time just to show what is actually happening. But I'm just going to, from now on, just do it in my head to save time. This is going to be equal to 1/2 log of x plus 1/4 log y plus 1/4 log of z. And this is the final solution, simplified, or I don't know if it's more simple or not. Depends how you look at it, I guess. But either way, it's a fully expanded logarithmic expression. So let me do one more, and then we'll start contracting them. Actually, I'll do that in another video. Well, let me do one more. I'll do... That's a little bit small. Log base 4 of x squared plus 9 over x squared minus 6x plus 8 raised to the 2/3. So here there's a couple different ways to approach it. We can do the power rule first. We can do the division rule and turn it into the difference of two different logs or whatever. But I'm going to do the power rule first. I'm going to say that this is equal to 2/3 log base 4 x squared plus 9 over x squared minus 6x plus 8. And now I'm going to use the division rule or the subtraction thingamajig, whatever it's called. Doesn't matter. And again, this 2/3 is going to be distributed to both terms. It's very key to remember. So I'll do it one more time. Actually, no, yeah, I'll do it one more time. Just to make sure that everyone remembers this, because this will cause a very many wrong answers. So 2/3 log base 4 x squared plus 9 minus log base 4 x squared minus 6x plus 8. And here it's easier to see that this 2/3 is distributed to both of these logs. So let me do that. So that's 2/3 log base 4 x squared plus 9 minus 2/3 log base 4 x squared minus 6x plus 8. And now we have two quadratic equations that can be factored and simplified. This x squared plus 9, that's x plus 3 times x minus 3. And this can be factored out as well. Two numbers that multiply to be 8 and add to be minus 6, minus 4 and minus 2. So I'm going to simplify both of these expressions, and then they're going to be two linear factors being multiplied together, and therefore I can break them apart. So let me simplify these expressions first. So this is 2/3 log base 4 x squared plus 9 can be written as x plus 3 times x minus 3. This is minus 2/3 log base 4 x squared minus 6x plus 8. This can be written as x minus 4 x minus 2. And now we have some multiplication taking place, so this can be simplified further, or expanded further, I should say. It's not really simple. It's just being expanded. So I'm going to expand both of these. Actually, let me expand this one first because I want to show where somebody might make a mistake on this other one. So I'm going to expand this left side first. So if I expand this, this is going to be 2/3. And again, this is going to be distributed to both logs. So log base 4 x plus 3 plus 2/3 log base 4 x minus 3. And then we still have this other term over here that I haven't simplified yet. Or expanded, I mean. So this 2/3 was distributed to both. And the reason I want to talk about this one is because this has a minus sign. And I know what someone is going to do. Let me write this in a different color because it's wrong. Let me put it in, I don't know, or I'll put it in this color. I know someone's going to take this expression right here, and what they're going to do is they're going to expand it like this. They're going to say it's minus 2/3 log base 4 x minus 4 plus 2/3 log base 4 x minus 2. And this is wrong. And the reason it's wrong is because somebody is going to put this plus sign here. And while it is an addition when you expand it for multiplication, you have to remember that there is this minus 2/3 in front, and it's going to be distributed to both of these logs. So it's going to end up being a minus, even though when we do break apart two things being multiplied together, it is addition, but this minus 2/3 is going to be distributed to both of them, and it's going to turn it into a minus. So let's do it properly. Let's write out the other term first that we already did. It's an ugly L. So let me write it out in the unnecessarily long way first. So minus 2/3 log base 4 x minus 4 plus log base 4 x minus 2. And now distribute this minus 2/3 to both. And this is going to become a minus. So the final answer, 2/3 log base 4 x plus 3 2/3 log base 4 x minus 3 minus 2/3 log base 4 x minus 4 minus 2/3, not plus, log base 4 x minus 2. And this is a 100% correct answer.